My name is Walter, and I'll be talking about deploying learning algorithms for real-time health optimization. So to do that, I wanted to introduce the concept of a micro-randomized trial. I think many of you know what this is, but it's an experimental design in order to answer questions to inform the building of a just-in-time adaptive intervention, or what I call a JEDI. I'm going to start with a quintessential example from our colleague Peja, who's not here, I believe, in a study called Heart Steps. So Heart Steps is a 6-week physical activity clinical trial for improving the physical activity of sedentary adults. I believe Peja's on like Heart Steps V5 or V6 now. This was in sedentary adults, but you can think of similar studies in the context of a hypertensive population or cardiac rehab. In these studies, you're typically given a Fitbit tracker and a mobile phone application designed to help improve proximal physical activity. The type of messages you might receive, although I think it might be too hard to read, so I'll read it out loud. These are types of messages you would get on your through Heart Steps. The example is, what warm, healthy treat could you make today? Maybe tea or soup. You could do squats or jumping jacks while the water heats up. I do not write these messages. If you're interested in finding out more about how these messages are created, happy to talk offline. There's a lot of interesting work now on the use of large language models to actually think about how to scale these up. But today I'm going to focus on just the notion of when should we appropriately send these types of messages. So the question that Heart Steps was asking is, can we devise a just-in-time adaptive intervention to improve physical activity and through this improve long-term health outcomes? So the key question is, how and when should we send these messages, in what context and at what time points? To do that, the MRT will sequentially randomize an individual. So this diagram here is Heart Steps in, you can think of it as a sequence of observations, actions, and rewards. So at every single time point, you observe a set of actions. These can be a mixture of passively sensed things through the wearables as well as mobile data. So in this case, we have access to the location, the weather, motion through the wristband, as well as any self-reported physical activity. I'm going to walk you through the top part of this diagram. So 5 times a day, individuals were potentially randomized to receive one of these just-in-time adaptive interventions. But first, we got to check a few things. So I'm going to point out here that we have different things that measure whether it's feasible or ethical to reach out to an individual. So the first thing is, if you're driving a car, it's usually not a good idea to send a text message if I know you're driving a car. And so the first thing we check is, are you driving? The second thing is, if you're already currently walking, it's also inappropriate to say, why don't you go for a walk right now? Because you're already going for a walk. So we also check if the individual is walking. These are things that were built out by a set of software engineers I'm not going to talk about today. What I'm going to focus on today is this R right here. So if you are not driving and not currently walking, we randomize this individual to potentially receive one of these tailored prompts. Here you can see it says R and then average, or you can kind of see, I guess, the average 3 times a day. So on average, you receive 3 messages a day. In Heart Steps V1, this message was sent with probability 3/5. So it was a simple coin flip. With probability 3/5, you received a message. With probability 2/5, you did not receive a message. And then we measured your physical activity through the wearable device in the next 30 minutes. And so the question we were trying to answer is, how do these messages, do these tailored prompts actually improve your physical activity over the short term? It turned out in Heart Steps, we saw a positive signal, but that was sort of an average signal. So we had a sense of, on average, sending a message does improve your physical activity. The second question we wanted to ask, and the sort of where this field went, is moving towards more personalized decision rules. I think I had all Michigan themes. I think my blue background is gone, but that's okay. So here, the question is, now we're not trying to ask whether or not on average it's worth sending a message. But if we look at this diagram, this R that I was pointing out before, that was a simple coin flip, is going to move to an algorithm. So this algorithm that we're going to deploy is going to use data on the individual and historical data on that person to figure out, for me, is it useful in this context to receive a message? Now, how do you do that? And that's what we're going to talk about today, or I'm going to talk about one example of that. And then specifically, I'm going to talk about another study called Low Salt for Life that Mike Dorsch and Brahmaji Nalamothi ran. This was a study of hypertensive individuals. It does follow a very similar story to Susan's talk earlier, in which we have individuals who are hypertensive, and when they arrive at a grocery store or restaurant, we randomize them to potentially receive a message trying to get them to use our app that was promoting low salt alternatives. The question that we were trying to ask is, can we design a personalized decision rule using data collected on the individual? Now, to do this, you have a lot of issues that can come up. And today I'm talking mostly about issues. So similar to Susan, I'm going to talk a lot about problems that came up trying to run low salt for life. So the first thing is, when you do a simple thing like in hearts of the 3/5 coin, not a lot of decisions need to be made. When you're designing an algorithm, you need to now decide, what kind of model am I going to fit to the data over time? So in the field of reinforcement learning, you have to decide ahead of time, what model am I going to fit to the data that I have access to? Now, in low salt for life, the model, the context we had access to was a sequence of categorical variables. These categorical variables included things like whether or not you're at the grocery store or restaurant, what the weather outside was today, what time of day it was, whether it was the weekday or weekend, how engaged were you with the mobile app so far in the study, so we had a measure of engagement. And then we also have this thing called situation major, which is Google's attempt to figure out what kind of situation you're in. I won't talk too much about it. And so the first thing that the study team had to do was build a procedure through which we could build our model. And so in this case, we had a binary outcome. The goal was to get you into the app. And so for those of you who are familiar with logistic regression, we basically fit a hierarchical Bayesian model that accounted for the fact that you had a hierarchical Bayesian logistic regression model. Now, you still have some things to do. And I was mentioning to Adam earlier, I'm a statistician, so I get one math slide. And this is our math slide. So you do not have to understand anything here. I'm going to walk you through what it's trying to say. So specifically, I fit a hierarchical Bayesian logistic regression. What that means is I have both fixed effects and random effects. Why do I have these things? Well, on any given individual, there's not a lot of data, right? So I only go to the grocery store. Well, I go to the grocery store a lot because anyways. If you are, the standard individual has roughly 2 to 3 times they go to a grocery store a week. And so on a given individual over the course of a month, I'm not going to have a lot of data on that one person. But if I recruit 200, 300 people into a study, I have a lot of information about additional people that I might pool across people. And so the hierarchical model allows me to pool information across people while also building personalized rules. And so what we did in this slide here is just write down the exact model we fit. In particular, the way we fit this model is we basically shrunk the overall population to look similar, and then we also shrunk the individuals a little bit more. And so higher order effects, meaning interactions of context and action, those got a lot of shrinkage, so they had to have a huge signal to turn on. And so what this allows us to do is allows us to build this model over time and have the model not break. So one of the other problems with running reinforcement learning algorithms, and when you deploy them in the real world, is they can break because you're trying to fit a very complicated model to little data early on, but you want a complicated model because later on in the study you have a lot of data, and so you want to learn things. And so this sort of shrinkage method allows you to do that. The other thing I want to point out is this shrinkage method that we derived was basically a balancing act. If you have too simple of a model, you won't learn anything. If your model is too complicated, you're going to have to take you're going to need a lot of data to learn anything. The more complex your model is, the more you have in terms of you need more data to make it learn. And so this model that we fit, this low salt for life model, this picture is just trying to tell you that it balances these two things. We basically compared to a simple model and a complicated model and showed that our low salt for life algorithm is sort of the best of both worlds. So we have an algorithm, now we need to deploy it in the real world. When we deploy it in the real world, I just wanted to mention that this means we have to work with a software engineering team to do that. When you're working with a software engineering team, there's a lot of issues that come up just that are not statistical anymore. And so our solution to deployment was to build these things called megatables. These megatables allowed us to deploy at scale and make it quite easy to deploy. The last thing I wanted to mention on this is that we also have to do monitoring. So for those of you who are used to clinical trials, there's a lot of monitoring in clinical trials. Here, on top of traditional clinical trial monitoring, you now need to monitor your own algorithm you've derived. So in this context, I've derived a really complicated Bayesian algorithm that tells me with what probability I'm going to send a message. I have to make sure the algorithm's actually doing what I told it to do. So we actually had to derive a second algorithm that was basically a calibration test to make sure that we're sending these messages with the probability that we thought we would be sending them. And so this is work by Rachel, who's over here and has a nice poster that is now, oh, the poster's gone. So if you want to talk more about it, you can talk to Rachel. And then lastly, I just want to mention one last area that we work on a lot, which is, okay, we've run these algorithms. We want to understand, based on the data that we've collected, it's one thing to deploy an RL agent. It's another thing to analyze data that comes from one of these studies. What do we do once we have this data? And one of the things that we're really interested in doing is identifying potential moderators. So in the algorithm, we had ones we've chosen. There's also other candidate tailoring variables you could have chosen. Now, the way we did it historically is we went one at a time and looked at every potential moderator one at a time. We flagged the ones that might make sense, and we sort of strung together a bunch of these, what I call a sequence of single moderator analyses. These have problems because they lead to a large high false discovery rate. And in recent work, what we've done is we basically come back to this problem and thought out about how to do it in a more holistic fashion. And so with my colleague in statistics, Nigda Panagrahi, we have a method that allows us to basically analyze all potential moderators at once. And here I'm just going to show it to you in the context of the Valentine study, which is very similar to HeartSteps, but it's by Jesse Golbis and Brahmaji Nalamothu in the context of cardiac rehab. And here, what I just want to point out with my last negative 30 seconds, is while we often think about time as being the most important in a lot of studies, when we run these sort of holistic, checking all potential moderators at the same time analyses, we find different variables that we didn't think would matter. And so in this particular instance, the types of things that matter that we found after running this analysis are things like baseline step count, as well as the step counts recorded in the prior 30 minutes. So it wasn't time and study that ended up mattering as much as we had originally thought, but what mattered more is the amount of distance you walked initially and how much you're walking currently. So it's this balancing act that we saw in our analyses that will inform future RL algorithms. And with that, I'll thank you and leave you a nice picture to offset the math that I showed you.
Hi everyone, my name is Meng, and today I'd like to talk about one of recent work collaborated with Stringent's lab, and this project is about personalized insights of improving well-being with wearable data and large language models. So this is a little bit background. So we know that health behaviors such as physical activity and sleep affect mental health, but the effect of each individual, each health behaviors are different across different individuals. Despite recognizing of this effect, there remains limited evidence specifying which behaviors are most critical for optimizing mental health in which individuals and contexts. So we know that the digital health technologies can continuously and passively measure our physiological features. So these digital health technologies provide a potential prevention technique to address this limitation. So in this study, we used the intern health study and to examine the individual level associations between wearable features and the mood dynamics. And we further developed a large language model powered system, we call it a mood driver, to generate tailored feedback emails that inform participants how their behaviors relate to their mood. So let's first look at this heat map. It shows you the correlation between each wearable-derived features and the mood scores for each individual across the whole intern year. So the red color represents the high correlation, and the blue color represents the low correlation. So we can see that in each row that represent for each wearable features, for each features, they have both positively correlation. They have both positive correlated individuals, also the negative correlated individuals, but also those features can be not correlated with those in some of the individuals. So it shows us a heterogeneous pattern of mood and feature correlations. And on the right-hand side, actually we found about 20% of the individuals whose mood do not correlate with any of those wearable-derived features. And based on those correlations, we further group those individuals into 3 groups. And that is the non-significant correlation group, significant positive correlation group, and a significant negative correlation group. So we can see in the bottom plot, and for each feature, the group of the non-significant correlation individuals, they are the dominant. So, and we further investigated the temporal dynamics of those of the mood and feature correlations. Now, for each culture, we calculate the correlations and further group the individuals into data 3 groups, and then and this plot shows you the transitions among those 3 groups across the 4 cultures. So we found the transition between the non-significant correlation group to the significant positive correlation group, and the transition between the non-significant correlation group to and the significant negative correlation group. They are the dominant one. So this indicates the transition, the fluctuations. Actually, it is in the strength of the correlation, but not in the direction. So we are already seeing that actually the mood and correlations, they are quite heterogeneous. And so this underscores the importance of the personalized adaptive feedback. And we also quantify the effect size of each feature on the mood. So here we simply apply a simple linear regression model, regressing the mood score on each variable derived feature. So we can and this linear regression model, and we fit it at the individual level. So actually, you can see that there are still a lot of variations across different individuals. So here the slope information, from the slope we can learn the change of each feature associated with the change of the score points. Actually, we will use this information and to give the feedback to the interns. So based on the result of this analysis, we developed this LLM-derived mood feedback, the mood driver. So this mood driver, and they will use. We designed these customized prompt instructions, and then this mood driver will generate the feedback emails. So let's look at some examples. So here and so for each for those emails, so we will start with acknowledging the participants in this study and give the data range for the study. And the mood driver provide personalized insights by addressing these 3 questions. The first one is how is my mood affect in my sleep, physical activity, and heart rate patterns. And then the mood driver will answer this question in several bullet points, such as for an individual with multiple drivers. And the mood driver will say that those features are linked with a better mood. And then such as in the second bullet point, it will give us for each additional hour of the sleep, and your mood score will increase by 0.8 points. And then after those points, and then it will follow the gateway message and highlight those significant features, and ask the users to prioritizing those features. They are the key to improve your mood and well-being. So such as for an individual with no drivers, such as in the first example. And then we will mention that there could be some other factors, such as the nutrition, daylight exposure, and may be more important to you. And then in the second question, what does my mobile data look like? And then the mood driver will give you a summary of the summary statistics for each variable features, and it will give you the mean value and the range. And in the third question, and it's how consistently have I been providing mobile data? So the mood driver will report the completeness of each feature. And then at the end of each message, we will always encourage the users to maintain the consistent data collection, and saying that providing more data will give us a more we can provide more clearer and better reliable insights. So, and this is some email examples. And here I showed you some representative individuals, and the mood drivers can provide adaptive messages to different individuals. So as a summary, and we found in our study, demonstrated the mood behavior relations are quite dynamic and heterogeneous. And here we combine the continuous variable data with large language models, and our mood driver framework translates personalized statistical analysis into interval data-driven feedback and supports self-awareness and mood regulation. And this approach offers a scalable path towards a precision digital mental health. So with that, I'd like to thank our collaborators. Kai was my former postdoc, and Yu, Alina, Amy, and Stringent gave us a lot of valuable feedback and comments. And we also like to thank the medical interns and our funding resources. Yeah, thank you for your attention. Yeah.
Okay, hi everyone. My name is Emily Diamond. I'm a PhD candidate in the psychology department, and I'm really excited to talk to you all today about how my lab is leveraging technology to gain new insights into the science of relationship initiation. So decades of research has demonstrated the importance of high-quality relationships, specifically romantic relationships, for health and well-being. However, within the field of relationship science, there are key open questions about how people form relationships in the first place. So we still largely do not know why people click with or have chemistry with some people and not others, what makes two people compatible, and ultimately why any two people end up forming a romantic relationship. And beyond me being very curious and interested in these questions, answering these questions has important implications for how we can promote health and well-being over the lifespan. And one reason why we don't have the answers to these questions is methodological. So relationship scientists have yet to study people prospectively as they meet, date, and make decisions about potential future partners. And largely, the literatures on initial attraction and established relationships are completely separate from each other. But now, so much of people's social lives are online. For example, American adults most commonly meet their romantic partners online, and this is especially true for queer samples that have largely been underrepresented in relationship science. So you can see here on these graphs, that red line is showing the spike in people meeting their partners online over time. And so far, dating apps have largely been for-profit businesses, so relationship scientists largely don't have access to this data. This prompted my lab to develop Revel, which is the first dating app built for science, and this is a dating app specifically for University of Michigan students. This project is a collaboration between the psychology and sociology departments and is led by Drs. Amy Gordon and Elizabeth Brooke. So Revel is both a research study and a real swipe-based dating app. What makes Revel unique from other dating apps is the built-in research components. Once people set up their profile, they're filling out 2 surveys. The first survey is about themselves, such as their personality, their dating history, and their beliefs. And the second survey is about what they would ideally like to find in a partner. Okay. And then within the app, participants can complete further optional surveys about themselves. We also have swipe-based surveys. So this allows us to capture why users are interested or not interested in specific people as they make these initial swipe decisions. So there's a little pop-up saying, why were you interested in this person? Or why were you not interested in this person? We also built a relationship tracker so users can monitor where they are in the dating process with each of their matches. So each time they move the tracker forward, for example, saying, we met in person, this prompts a survey and they can tell us how they're feeling about that specific match. So this allows us to gain insight into how people feel about their different matches, as well as how those feelings might evolve over time throughout the initial dating process. And finally, the app includes an insights feature that actually feeds the data that we're collecting about the users back to the users. So it allows people on the app to learn about their own dating habits and patterns, as well as those of the larger sample at the University of Michigan. Okay, so we piloted Revel in early 2025 and fully launched to the school this past fall. In one semester, we already have over 1,300 total users. There have been over 88,000 swipes, 1,100 matches, 18,000 messages, and over 7,500 surveys completed. And it's always exciting. We're still doing a lot of in-person recruitment events around campus to try to get people to join Revel if they're interested. And it's always so exciting to meet people who come up to us and say that they've met their partner on Revel, or that their friend or roommate met someone that they're dating on Revel. So it is working for some people. And an exciting extension of this project is this, it'll just come when it comes. Okay, all good. An exciting extension of this project is an in-lab study where we actually invite Revel matches, as well as broader people from campus, to come into the lab to have a real first date in our lab. And in this study, we're able to examine how first date interactions unfold in real time. So we're collecting self-report, behavioral, and physiological data before, during, and after the date to really better understand what makes these initial interactions go well, and whether we can use these measures to predict people's interest in each other after the date and actual behavioral outcomes, like if they see each other again or start dating, which we're measuring through longitudinal follow-ups after the interaction. And because this is a symposium on mobile technology, I also wanted to highlight the wearable physiological measures we're using for this study. So far, our lab has used the bioharness chest straps to collect ECG data. Oh, here we are. Okay, we are now transitioning to using the BioPack research rings, which collects ECG, PPG, EDA, and temperature. And this is a really non-intrusive way to collect physiological data from these participants as they're interacting in real time. So it allows them to touch, move around if they want to, and just generally more naturally interact with each other. And overall, we're really excited to be able to use this data from Revel and the in-person first date study to address key questions in relationship science. For example, there's been a lot of research, a lot of literature showing that what people say they ideally want in a partner is actually not good at predicting who they're especially interested in or attracted to once they meet in person. So this begs the question of what actually is important in predicting these outcomes. So through these studies, we can put different things to the test. We can see whether people's stated dating preferences and look at how those compare to perhaps their felt chemistry in predicting romantic interest. Similarly, we can examine whether compatibility is something that can be identified before people meet, for example, by looking at their trait level features like their personality or their beliefs, or if it really is something that emerges through interaction, whether through online conversation or in-person interaction. And finally, I'm especially interested in really examining what features of these conversations, both online and in person, predict romantic interest and actual relationship formation over time. So there are so many theoretically relevant factors that might be important here, including banter, humor, linguistic alignment, responsiveness. I specifically study a lot of processes related to synchrony between people. So my lab is really interested in putting a lot of these factors to the test to see what is most predictive of these important behavioral outcomes. Overall, by leveraging technology and wearable methods, we're able to meet people where they actually are at when they're dating and track them prospectively as they chat online, meet in person, and potentially even continue to date. Thanks so much.
All right, last talk, you're almost there. Hi everyone, I'm Libby Benson, and I'm really excited to talk to you today about personalized feedback data visualization. So I'm sensing the theme in this symposium for expectant parents. So different population, but pulling through this feedback theme. So there are 3.6 million expectant parents in the US annually. And this is a critical period of vulnerability for mental health because these parents are at risk for, or at elevated risk for depression and anxiety, which affects up to 20% of mothers and also 10% of fathers. And perinatal mental health problems disrupt parenting, impair child development, and cost the nation somewhere around $14 billion annually. And the US Surgeon General has actually declared parental stress and mental health as a public health emergency. And so on the bright side, we know that emotion regulation is a key protective factor for mental health, and that strong emotion regulation skills include the ability to recognize and manage emotions under stress. However, there's very little mental health support available for expectant parents, as some of you in the audience might have experienced yourselves, right? The majority of existing prenatal care is focused on birth and child outcomes rather than on parental mental health. And so mobile health interventions offer a promising, accessible solution. But there's also lots of key exciting challenges to address here. So one of them is that stress compromises emotional awareness and the ability to recall effective emotion regulation skills. And another one is that low engagement decreases intervention's potential effectiveness. And so back in 2024, I was part of the Mobile Health Training Institute, which is an NIH-funded training institute where they pair you, or they put you in an interdisciplinary group of scientists. So in my group, there was a clinical psychologist focused on mental health and the transition to parenthood, my expertise in just-in-time adaptive interventions and also personalized feedback. And then we also had a computer scientist focused on human-computer interaction. And from our interdisciplinary collaboration, we formed this stress tracking and regulation plus reflective support project, where our idea was that a just-in-time adaptive intervention could transform emotion regulation support for expectant parents by prompting engagement in emotion regulation skill activities such as mindfulness or deep breathing or other types of skill-based activities that one can do in a mobile app to disrupt the link between stress and negative emotions. And also by providing personalized feedback visualizations as a strategy for increasing engagement in the app-based emotion regulation skill activities. And so in terms of our STARS intervention optimization pipeline, we've submitted a grant, but in the meantime, and to support that grant, we've been conducting some preparation phase research, including a scoping review where the goal was to synthesize existing knowledge and identify gaps in the science of mobile health interventions, targeting perinatal emotion awareness and regulation skills. And we also just wrapped up data collection on a co-design study where we were looking to examine what are the needs and preferences of expectant parents for a mobile health app focused on improving emotion regulation. And I was joined by a really amazing team to do all this research. And hopefully about a month from now, NIH will also be in our favor and fund us to keep going on this work and to actually do the micro-randomized trials to optimize this JEDI and down the road, even evaluate this optimized JEDI against a suitable control. But the focus of my talk today is to talk about this preparation research that we've been doing in terms of the scoping review and the co-design study. So for this scoping review, we worked with a Tubman librarian actually right before. So if you're in a health sciences department, you can still work with them. I'm hoping they're going to put back resources for the university at large, but it was really a great experience working with the Tubman librarian for this particular scoping review. And we started with over 3,000 articles that we winnowed down to actually extracting data from 39 articles. And a few selected findings include that we looked at intervention optimization phase and found that the majority of studies were in the preparation phase. We didn't find any actually in the optimization phase, and that about a third of the studies were in the evaluation phase. In terms of intervention delivery modality, most of them delivered their digital intervention through a smartphone app. Some of them used just text messaging alone without a standalone app. And then only one of the studies that we identified actually included a biosensor to deliver the intervention. Some had biosensors as research assessments, but in terms of intervention delivery, only one used a biosensor. pertaining to personalized feedback, we found that 10 of the articles, so about a quarter of them, provided text-based feedback to expectant parents, and 5 of the studies provided some sort of data visualization feedback. Okay, so the next piece of preparation phase research we did was with first-time expectant parents recruited from LA County. And what we did is that we had both a quantitative survey as well as a Zoom-based interview where we walked these prospective parents, these were first-time parents, through our ideas and the purpose for this app that we wanted to design, and including asking for their feedback on the key app components, including a biosensor for tracking physiological stress and for initiating prompts to use emotion regulation skills in times of heightened stress, training in evidence-based emotion regulation skills, regular check-ins, and then also visualizations of their personalized data, plus giving them some feedback. And so a few quick results, but generally these results suggested that the STARS mobile health intervention concept was acceptable to these first-time parents. We found that 84% of them were already using some sort of pregnancy tracking app, but that less than 10% of them were using an app that had anything to do with their mental health. We found that parents were strongly interested in additional tools to manage their emotions and stress. So this is one quote from one of the pregnant women where she said that evidence-based activities / strategies for managing emotions would be very helpful, and reminders to take time to de-stress when the tracker can tell that I'm entering a state of heightened emotion would be helpful. It would be another way to monitor and care for myself. It gets more difficult to remember as my body gets more pregnant and needs more physical care. So participants also reported that visualizations of their personal data were useful and enjoyable. So this is a quote from one of the partners, actually. So this partner said that if I notice progress being made with decreasing my stress levels, I would be more inclined to keep using it. And so this supports our idea that these personalized feedback visualizations can be used as an engagement strategy to keep people coming back to these mobile apps and using the different intervention techniques that we're providing to them in the apps. In terms of most highly rated feedback data visualizations, people really like the idea of knowing which emotion regulation skills most reduce stress. They liked the idea of looking at changes in their physiological stress before and after using an emotion regulation skill activity, and also knowing which stressor types were most prevalent for them. Their least highly rated visualizations included the number and types of app-based ER skills that they were completing. And so this is a really notable finding because this is the typical type of feedback that's provided in most commercial apps, right? Whether you're using the different types of skills. And so I think that there's really exciting future possibilities to go beyond this and to provide potentially things like actionable insights. So I have some resources. There's a ton of QR codes. Happy to share these slides for this Mobile Health Training Institute that I was part of. A link to the Topman Librarian site for doing scoping reviews. Also, I'm part of the Data Science for Dynamic Intervention Decision-Making Center, where we have lots of statistical software, experimental design, learning resources, and workshop information available. And then I want to give a quick plug for a completely new conference that we're putting on in May, and also some insider knowledge that we haven't announced yet, a late-breaking call for lightning talks and posters, but this will be coming. So if this is of interest, please send me an email and I'll make sure to get you on the listserv for when that's announced. And so I'm about to wrap up, but wanted to give a few quick shout outs to participants and staff involved in collecting these data, to the funding sources, colleagues and collaborators, my amazing lab members, and then also just general colleagues who have influenced me over time. Thank you all so much.
Yes, this question is directed more toward the relationship app. Relations they vary between more emotional or physical, and I guess your database thus far is the students, but depending upon the nature of the relationship, I would imagine online tracking would be more or less relatable to the. And the other thing is. It'd be interesting to expand the cohort for people like on the autistic spectrum, or people who how they identify, as sexually, and also people who are disabled. Just to see how these correlations go. Thank you.
Is this on? Yes. Well, thank you so much for that comment. We are definitely, so right now the sample is all possible University of Michigan students, and we have separate pools for undergraduate students and graduate students. But you highlighted some important subgroups or specific populations that might be of interest. And although we're not over recruiting for these groups at this point, we are testing all those things. So we ask people for their, like if they have disabilities or autism, and we definitely ask people about their sexual orientation. So we really want this app to be inclusive of people of all different, again, genders, sexual orientations, ability statuses, and we can look into whether dating works differently for different people. And also your first comment about how people date differently or maybe have different goals, we also are assessing that. Are you seeking a short-term relationship? Are you seeking a long-term relationship? Sometimes people don't always know what they want and their goals doesn't actually match up with what happens, but it's interesting to see how people's frameworks might impact their behavior.
Hi, my question was also for the dating app study. How are you protecting participants? I know it's common where some individuals might experience discriminatory messages or explicit images. So what are some things that you're doing to protect others from that?
Yeah, definitely. So first of all, just want to highlight that because this is a research study, there is we work directly with the IRB. Everyone consents to participate in the research before joining the app. There's also unique features of the app. For example, people can preemptively block certain people by using unique names before they start swiping. And then we also have, originally there was kind of a progression of this. Because we're not monitoring data in real time, initially we wanted to not have a reporting button just to signal to participants that because we weren't monitoring in real time. But it was actually not the IRB, but when we wanted to put it onto the Google App Store, on the App Store, Google had some requirement about including a reporting button. So we do have different protocols in place to make sure that people are doing it safely. But generally what we talk about is it's not more unsafe or any different than people deciding to join another dating app. In fact, because we have this narrow sample of Michigan students, we hope that it's better for people.
Got it. Thank you.
Hi, my question is for Dr. Benson. I've worked with expecting mothers, so your app really highlights some questions in my mind about what did you find the best way to instruct expecting mothers on how to download the app, how to navigate it, and how to best customize it to what they want to get out of it?
Yeah, thank you so much for the question. So a lot of what this co-design study was meant for was to get some of that feedback. And so one of the pieces of feedback that we got was that they wanted sort of brief modules rather than like a long training session at the beginning to teach them about all the emotion regulation skills at once, but rather wanted to be fed these in brief modules and be able to go back to those if they wanted. And so we have onboarding protocols that we're working on for initiating people's experience within the app. And then, yeah, you're totally right that another thing that came out is that people are really interested in specifically having content tailored to the specific, specific things that happen that are unique in the transition to parenthood. And so we're working to incorporate those in terms of the types of unique stressors that transitioning parents or expectant parents are facing, things like that. But I think you raised a really good point that, when we design these mobile apps, right, the extent to which we can have, effective or engaging onboarding procedures so that people actually come back for a second session, right, and don't just download we know that lots of times, the modal usage of an app is once, right? So we really need to get that onboarding procedure correct.
Thank you. I have a question for Dr. Meng. In your LLM-based study, how did you incorporate guidelines for inappropriate or overconfident advice or feedback?
You mean how to confidently get the feedback from the users?
Or rather, guidelines for the model.
The guideline for what?
For the model.
Oh, for the model. Okay, yeah. So and here actually when we do the LLM prompt engineering, we follow an email template. So you can see that you can for each users, and they have in the same format. They will receive the similar format. The emails in the same format. So here such as they have the 3 questions, and all the users will have those 3 questions, and then we use the LLM especially to to summarize those results to the sentences. So but the format is the same. Yeah, we take that email template as our guideline. Yeah.
Great talk by all of you, but my question is for Emily. You talked about dyadic synchrony. Could you say a little more about what was measured, what was the time lock, time signature of that, and what are the implications of synchrony from your work?
Yeah, definitely. So, I mean, it's interesting. Right now I'm wrapping up a long project looking at the role of synchrony in established relationships. And so for this work, I'm looking at synchrony across multiple domains. So cognitive, emotional, and physical synchrony. So that can be things like people riffing off each other's ideas or agreeing with each other for cognitive synchrony, shared laughter or experiencing similar emotions. And then even on the physical side, people coordinate their behaviors or their movements. And in this work, I've looked at like bidirectional links between synchrony and relationship quality. And generally, we see that couples in high quality relationships are showing these behaviors more often. There's also been a lot of work looking at this among strangers. But for this work, for applying it to Revel and the first date study, I'm really interested in looking at whether these synchronous behaviors not only are features of high quality relationships, but might actually be important behaviors that predict the formation of relationships. So again, there are these observed types of synchrony that I just mentioned, but you can also think about synchrony at the level of your physiology. So we are collecting ECG data and other types of physiological data, as I mentioned. So I'm also really interested in looking at whether this physiological synchrony during these first dates, or even thinking about the chats like linguistic synchrony or shared language might be important in predicting relationships. Yeah.
I have a question for Walter. All right, so we know that you're very successful and important now, but back when you were a young, naive, budding adaptive intervention researcher, what mistakes did you make? What did you wish you had known? What advice would you give to people who are trying to get into this space?
Oh, easy question. Okay. Yeah, I guess biggest advice. So I think it was actually illustrated a lot with both the dating app and then the every project here, but team science being the most important element. I think one of the difficulties being a junior faculty or a junior researcher is you need to show independence, show that you're contributing your own to your own trajectory. So you have to do that, but you have to navigate that with the ability to run these types of studies. So one of the things I had to realize quite early on is if I want to deploy these algorithms, I need them to actually be useful, so I need to understand the domain science. I need to understand how to deploy them, so I need to understand the computer science. And I need to actually write the algorithms, so I need to do the statistical or data science. I can't do all three. I mean, yeah, I haven't met someone who's able to do all three. And so you pick one to be the thing you're going to lead on, but you need to find the team you're going to work with, and you're going to work with long term. I think the two things I realized early on, and again, I credit Susan Murphy, who is my postdoc mentor. She's collaborated with the same people. Actually, Libby's slides are gone, but the QR code is for Linda Collins is running that conference with Billy and Susan. And they've worked together now for, I don't want to put it out. I mean, it's decades, we'll say. And so I think Susan was always advising you find the right people, you work with them long term, and you find the complementary people. And so for me, the types of things I've been doing, I think finding the domain experts who are interested in deploying these algorithms, but also finding the computer scientists who are able to help me scale these up. I think that's been pretty much what's helped me get to where I'm at.
All right, one more round of applause for our amazing panel. All right, and we have about a 5-minute break till 3:45, and then I'll have you guys come back for the final research spotlight.